So thank you for joining us today for Student-Centered Mathematics in a Virtual Environment, supporting equitable, ambitious learning and teaching for all. We're going to take some time to introduce ourselves. My name is Sherry Zub, and I am one of the math consultants at Wayne Risa, and I will let my colleagues introduce themselves.
Good afternoon, everyone. My name is Christy Hamby. I'm also a math consultant at Wayne Risa. Happy to be here.
Good afternoon, everyone. I'm Sharon Ramsey, and I'm also a math consultant with Wayne Risa. Thank you and welcome.
So icebreakers. We really believe that icebreakers are important. They provide low stakes opportunities for all participants to share. There's so many benefits. There's no right or wrong answer, so it creates that low pressure environment. It helps to create that relaxed environment. It encourages students to share ownership for the learning. It builds rapport among the students and fosters a productive learning environment. And then, of course, it prepares students for the collaborative group work that you will be doing during math. So now, let's try out this icebreaker. What is your favorite number? I'm going to give you some time to think about that. What is your favorite number and why? So let's do that first. Think of your favorite number and why. If anyone would like to unmute and share their favorite number and why, we would greatly appreciate that. It's difficult to get into all the rooms to hear everybody. So if somebody could please unmute and share, we would appreciate that.
Hello, how you doing? My name is Everett C.J. Whitfield, and I say that my favorite number is 72 because that's the year I was born.
That's a good year. Thank you for sharing, Mr. Whitfield. Anybody else want to share?
You're welcome.
Hello. Yeah, my name is Mr. Barlow, and my favorite number is 94 because that was the year I was married.
Oh, that's sweet. Your wife would love to hear that, or your spouse would love to hear that. Thank you for sharing. Yeah. So when we think about a student-centered approach to mathematics, whether we're face-to-face, we know that a student-centered approach is still the best practice. So we need to consider our beliefs and really think about what we value. We have to create, we know, a student-centered, caring, and trusting environment of learners where they feel safe taking risks and making mistakes. We have to value those mistakes, where they feel valued as well as respected. We need to allow our students to engage in instructional routines that position them as problem solvers and to see themselves as resources in their classrooms. They need to know that they learn from each other. Their thinking needs to be visible. And what we mean by that is we can do this by providing opportunities to elicit and use evidence of student thinking in the classroom. And we'll be showing some of that a little later in this presentation. The essential instructional practices were written to promote high quality, equitable, student-centered teaching and learning. Now, these were released last October. While this is written for a pre-K third grade audience, it is applicable across all grade levels. We will be referring to the Tier 1 Ambitious Math Instruction Framework that was created by the Risa Math Department. Now, the essentials, along with this Tier 1 Ambitious Math Instruction Framework, will help us create that student-centered classroom where it's equitable and ambitious teaching and learning for everyone. So we know that our beliefs drive our practice. The essentials were built around 5 core beliefs or practices. And Sharon is going to be sharing that link out with you. And on page 1, you'll have an overview of the values, but if you look on pages 7 through 9 of this document, they will go in depth about each of these values. So again, they were created to promote equity for all learners. So research from Joe Bowler at Stanford says that children have to see themselves as mathematicians early on, as that belief is essential to future success in math. So we really need to focus on having great experiences for our younger learners so they can learn to be successful. We value children's differences in their age, their race, their gender, their ethnicity, and their socioeconomic status. We value math as a creative, collaborative discipline for sense-making and problem solving. It's not about speed, it's not about procedure. It's about helping us make sense of our everyday world. And we believe that math teaching focuses on relationships. It's about building relationships with our students and letting them know that we value and honor their thinking, that we value them as a human. And these beliefs will lay the foundations for students to build their mathematical understanding. So now you're looking at this document. I stated earlier that this was created by the math department here. This is a pre-K-12 document that supports equitable and robust learning gains in math. Now you'll see that the number sense routine is built into the framework. This is the yellow portion on the framework. This routine helps students develop number sense and procedural fluency. We recommend a number sense routine through high school. It was beautiful. We had the privilege of listening to Dr. Robert Berry speak. He is the president of the National Council of Teachers of Mathematics, and he told us that they are now recommending that high schoolers be engaged in number sense routines. So we were pretty happy about that. Now the green portion is the main lesson or the math task. When students engage in number sense routines and these math tasks, this positions students as problem solver and builds their self-efficacy, and they'll be independent over time. This instruction allows for real-time assessment where the teacher is posing those really great questions, those purposeful questions to assess and advance their learning. This really is formative assessment at its finest. The instructional framework is aligned to the practices 3, 4, 5, and 6. And again, Sharon, I just want to make sure that that link to this document is again in there in case we had somebody who just came into the meeting. So the essential practices and a student-centered approach. Let's think about that for a minute. Essential 6 is aligned to our framework. Again, that's the yellow portion of the framework. For Number Talks, we recommend these two resources at the top. They're kind of housed between the title and that framework. These resources include so many purposefully designed Number Talks. And the beauty of it too is that you'll be able to access streaming videos of Number Talks filmed in classrooms at a variety of grade levels. So what I would like you to do is take time to read Number 6, and Number 6 happens to be on page 6. So if you will go ahead and find page 6 in the instructional practice document that Sharon has placed in the chat. And as you read the bullets, I would like you to look for evidence of a student-centered approach. Again, as you read those bullets in Essential 6, on page 6, I want you to look for evidence of a student-centered approach. And as you discover the evidence, would you please type that in the chat box for us? Again, we're asking you to read the bullets for Essential Practice Number 6, where we're regularly engaging children in brief interactive number sense routines focused on developing mental math strategies for seeing quantity and working flexibly with numbers. And then add the evidence in the chat box.
I see students are engaged and share their strategies.
Yes.
Emphasizing sense making and eliciting children's thinking.
I like that. They have to do they have to use the strategy that makes sense to them. Yes, thank you.
The teacher is recording the student's thoughts even when incomplete.
Yes, I love that. We value incorrect answers so that the children are able to think through and correct their mistakes on their own.
Engaged, making sense of math.
Yes. Yes.
Develop-
Go ahead, Sharon.
Developing their own strategies.
Exactly. You have hit the nail on the head with these student-centered approaches, and it's really important that the students are engaged in Number Talks regularly. So now we are going to have the privilege to see a synchronous virtual Number Talk in action. We're going to zoom into a second, third grade classroom in Wayne Westland. This teacher so graciously recorded her number talk for us, and we are so appreciative to her. So I just kind of, we're dropping, for the sake of time, we're going to drop in at a certain space in the number talk, and I want to front load you on a few things. She has followed the format of a number talk. So she has displayed the problem, she gives the students time to think, and after students have had time to think, she collects all the possible answers from the students, and then she chooses students to defend their thinking to see if they have arrived at the correct solution. Now, in this first video that I'm going to show you, the students have shared their answers. 4 students said that the sum was 55. 1 student said that the sum was 35. And now she's asking them to defend their thinking. So she's going to call on a little gal and she's going to explain 39 plus 16. While you're viewing this video, I want you to think about what actions of the teacher were evidence of a student-centered approach. So if we think back to what we just read in that essential, what actions of the teacher were evidence of a student-centered approach? So here we go with this first video.
Something different from 35 or 55? All right, so now it's time to defend your answer. Does anybody want to share their strategy to defend their answer for 39 plus 16?
Mm-hmm.
Valeria, is that you? Do you want to?
Can I sure?
All right, go ahead.
So, first, I decomposed the, 16 into, 10 and 6.
Okay.
And, I decomposed the, 39 into a 30 and a 9. I did 9 plus 6. And then I got 15. So and then I did 30 plus 10. And I got 40. And the last thing I did is I did 40 plus 15. And I got 55.
And so now we're going to watch a video segment 2. And the teacher asks how a student could have gotten an answer of 35. And you'll see a student's thinking as to how a student might have solved it incorrectly.
35 right here. Can you think of any way that somebody could have came up with that? What do you think they were thinking? Any ideas?
I think I know.
What do you think? What might have happened there?
Talk a little bit later, okay?
Well, I think they like decomposed the 16 and then like took away 10 from the 39 and then they got 29 and then they added a 6 and they got 35. 35.
So maybe instead of 39, they were subtracting something away from here. They brought subtraction in.
Okay, so in just a moment, you're going to go into a breakout room and we'll let you talk with a small group. And I really want you to focus on what actions of the teacher were evidence of a student-centered approach. So remember, when you are prompted to join the breakout room, click the join button and chat with your colleagues about what actions of the teacher were evidence of a student-centered approach, thinking about this video. Hello, everybody. Welcome back from your breakout room. I hope you had some great discussions. And of course, not being able to get to all of those breakout rooms, I would love to hear from a couple of you. So if you would mind unmuting and sharing what actions of the teacher were evidence of a student-centered approach when viewing those videos.
In my group, we talked about how the teacher really gave ownership of this process over to the students, and how sometimes as teachers, that's not easy for us. You know, we want to make sure our students have the right information. We don't want them to become lost. You know, we're under time constraints, but to see her give them that space and that time to go through it without comments means that she was a true facilitator and that the students owned that time of learning.
Wow, thank you for sharing that. You lifted a lot of really important pieces, and it is so true. We have to give them the time. This little gal was really thinking through her strategy, and it took her a long time to verbalize how she was doing that. You're right, the teacher was so patient in valuing her thinking. Thank you for sharing. You lifted a lot. You lifted a lot. Anybody else like to share?
I also think it's really important for students to share and to show, because a lot of the times we hear that students learn from others. So just hearing how a student their age explains it, understands it, maybe another student says, oh, okay, I see where you're coming from. Rather than when we get up there, it's sometimes we use different words or just the rate at which we're speaking. So I think it's really beneficial for students to hear from other students and to say, oh, you know, so-and-so just displayed this. Next time I can go ahead and do it. That's something that I can do next time. So it's really powerful.
Exactly. I'm glad that you lifted that. She made that student's thinking visible when she recorded it on that whiteboard. And for other students who may not have thought of that strategy or were confused by the strategy, it now maybe makes sense to them. And you're right, they might try that strategy in the future. So it's so important that we make their learning visible and showing the evidence of their thinking. So thank you for sharing that. Let's see, and then our last, we're gonna go ahead and do a chat flurry now. And this was just one way that a teacher did a number sense routine, but I wonder if you could take some time, what other ways can you envision a number sense routine occurring virtually? How else might that happen? And we've done a few examples on the slide for you, possibly Jamboards or use an easel with chart paper in front of a camera. So can you think of some other ways that we could do a number sense routine virtually? Please feel free to write your comments in the chat.
Mental math arithmetic, a document cam, Flipgrid, Padlet, using Padlet, Smart Notebook, or Flipgrid.
Wow, these are great suggestions.
Images, using notices and wonderings over Google Meet, using pre-recorded videos on things like Flipgrid and having students respond on there. Have students record their thinking via video and send it to you, Class Dojo, Seesaw.
Wow, these are brilliant ideas. I'll wait a few more seconds for more to enter.
Google Camera, images, YouTube videos.
These are all brilliant. And I loved her low tech that she used. She just used that whiteboard right in front of the camera. That works well too. For those of us who are high tech and want to use some of those things that are mentioned in the chat, that's beautiful. But if you want to go low tech and do it on that whiteboard, with the pen, that's a great idea too. The important thing is that you're doing them. That's the really important thing. And one more thing I would like to share with you. These are some great stems that Sharon will go ahead and put those in the chat for you. These are great supports that helps your students engage in discourse with their peers. It's great for EL learners. It's great for any student. It just helps to facilitate discourse with their peers. So these have come in very handy in lots of classrooms. And we know that they will come in handy for yours as well. And with that, I am going to hand it over to my friend and colleague, Christy. Take it away, Miss Christy.
All right, so thank you, Sherry. So we're going to shift to another instructional routine. It's aligned with the essential instructional practice number 5, but it also comes right out of the research from the National Council of Teachers of Mathematics that we should be engaging students in cognitively demanding mathematics tasks. So if you would go back to the essentials document that you referenced earlier, and on page 5, you will find is essential instructional practice 5. And we're just going to ask you to do that same thing where you look through the bullets and you're looking for evidence of a student-centered approach. And just go ahead and put those in the chat once you see them. So page 5, we're looking for evidence of a student-centered approach. Working children's strengths. Yes, building from where they are, from what they know. Access for every child. Thank you.
Encourage and support children's perseverance. The struggle is good and allows them to understand on a deeper level.
Embrace the struggle. Support, but embrace the struggle. Use open-ended questions. This is really nice, right? So that it's the children's thinking. You're guiding through these open-ended questions. You're supporting them in making connections, but you're asking them in open-ended ways so that they can explore those ideas. Yes.
Prompt peer-to-peer mathematic talk.
Peer-to-peer talk. Yes, those heterogeneous and collaborative groups where they learn from each other. We heard Michelle say that students will learn from each other. Yes.
Launch tasks in a manner that ensures access.
Yes, so we are not going to just hand something over. We're going to make sure kids are ready, they have access, and they can engage in the work that we're asking of them. So I'm just going to share a little bit of background information on tasks to help support our learning, but then I'm going to go ahead and show the ways that we saw teachers in Wayne County doing some of these things that you're talking about here in the chat. They were working virtually with students this spring, and also some things that we have learned as consultants over the summer. And I just want to pause here to say that honestly, some of the best ways that we have learned is somebody has an idea, we figure out a way to make it work, or we notice that someone else has done that thing and we all try it out, and the next thing we know, we're folding it into our practice. So just using each other as resources, I just want to lift that idea. So what is a task? So a task is a vehicle that moves students from their current understanding toward the learning goals. It's actually where the conceptual understanding comes from, and it's how students move from conceptual to getting toward fluency over time. So here's some characteristics. We focus tasks around important conceptual ideas in mathematics, of course. We make sure that they're accessible, and by accessible, we mean that there are multiple ways that you could get started, right? So we're student-centered in that we're not showing them how we want them to do it today. We're making it accessible in that you could do it in a variety of ways. We make it relevant to their experience, and it could be relevant in really powerful ways, or it could just be, you know, part of their lived experience, something that they can relate to. We focus on reasoning and sense making as opposed to answer getting. So just like in that number talk, we're really focusing on the justification and the reasoning and getting to an answer eventually. And you'll see here in a moment that they naturally differentiate, which is a really beautiful thing for all of the other things that we're balancing in our teaching lives. Allow for some really deep connections between mathematical ideas. So to help put some texture to that, I'm just going to show you an example from early elementary and an example from middle school. So here's an example from early elementary. Okay. So if you think about those indicators, this is a problem that kids can relate to, having markers, two different people having some markers, and having to determine how many markers that is all together. And then they have to explain their thinking. And so there's some important ideas there about the task. And here we have two different students sharing, and you can see how it's both differentiated, but it has access for students who are thinking about this problem in different ways. Okay? It draws on their lived experience and it puts them in a language-rich environment, right? So them explaining their thinking is really language-rich. Just an example from middle school. In this case, students are having to compare the rate of rise from two different, a hot air balloon and a blimp. And not only do they have to say which is faster, but they have to explain how they know. And so again, we have students doing different things and being able to explain their thinking with lots of language. So you mentioned launching the task and allowing students to have access. So just a couple things to keep in mind, and it does mention this in the essentials as well, but we really have a goal of positioning students as being independent and collaborative problem solvers. So if that's our goal, students in that way, we might help them in reading the problem, in understanding the context, determining what the problem is asking, or being able to connect it to their own experience, or to have another student in the room maybe explain how their experience is with that context. What we want to avoid though, even though it might feel like it's necessary, what we do want to avoid is showing them how to solve the problem, because again, we're talking here about students finding ways to come up with solutions for these problems and then building that into more formal mathematics over time. So with that said, just some ideas that help with launch, and you can think about what this looks like in a virtual format, but maybe when you're with your students, you do something that's related but simpler, and then you send them off to do the more complex task. You might use context or visuals in order to help them make sense. You might remove the numbers actually so that they just think about the context, and then later we start to work with the numbers. You might have them give an estimate, talk with each other, do some sort of conversation with each other. What would be a decent estimate for this problem? And then really think about the math vocabulary that they're seeing in that problem. So here's an example of how a teacher was making this happen in the spring. The task was embedded in a Google slide, and every student had access to a Google slide. And as you mentioned, with different ways to do this in number talks, on this day, she asked the students to share their thinking in a Flipgrid, and also for students to go in and listen to one of their peers thinking and respond to it. So I'll show you here what that looked like.
Hi guys, here's my math for week 11. I'll read it to you. I used partial sum strategy. I added my hundreds first. So 300 plus 0 equals 300. Then I added my tens. 90 plus 40 equals 130. And finally, I added my ones. 6 plus 8 equals 14. When I added them together, my answer is 444. So here is my partial sums right there. And bye.
And then students had a chance to go and back into Flipgrid, view the videos made by their classmates, and then respond as we would do in a summarized phase.
Samantha used partial sums. It was efficient because she added her hundreds first, then added her tens, and then added her ones. I liked it because she explained it good. She did not solve it like me because I used an open number line.
Let's just take a second with the time that we have here, and if you want to unmute and say how you were using Flipgrid to gather students' thinking, or what you had to do to get them ready so that they could share their thinking. What did you notice, or who has had some success with this?
Something that I noticed was the use of sentence stems. I noticed that the kids were probably given some sort of sentence stem to really showcase what the other person was thinking while they give feedback, or even their own thought process, which I thought was super, super beneficial.
Yeah, so you could tell when the second little girl shares, there's 3 things it seems like the teacher has asked her to do. Explain the other student's thinking, was it efficient, and was hers similar or different? And those 3 stems sort of helped focus the student on how they would respond. Good noticing. Anything else? Okay, so sometimes students are going to be able to share in video, but we also notice comments in the chat about language impaired students. And so there might be other ways that they want to share their thinking. So here's a middle school example of a task. Probably won't have time in the moment to solve this task, but students have to figure out how many drums were sold with a bunch of other information from a vendor stand that was at a Caribbean music festival. So they have to figure out how many drums were sold, and they also have to represent that situation with an equation. And so another way that you do this is to have students insert their work. So they might have written their work out on a piece of paper or a whiteboard of some sort. And it turns out that there's a relatively easy way for students to insert their work in an image. And so as long as your camera is not being used by another device, so for example, right now I have my camera shut off. If I had it on, it wouldn't work for this. But inside Google Slides, you can just go to Insert, Image, Camera, and it brings up the camera from your computer, and you just hold your piece of paper in front of it and click, and you can insert an image of your student work. Be able to show you this way. Insert, Image, Camera. Can you see me and my camera? And then if I hold up a piece of student work and take a picture, I can insert that easily. The other nice thing that we noticed about working in Google Slides or some other similar format was, as a teacher, you could go in and leave feedback for students in the form of comments. And we have done this with participants. We have done this both as students are solving problems and also after they have finished solving problems. So anything anybody wants to lift about that?
Hello. Yes, I typed a message in there. It came out wrong, so I'm just gonna verbally say my question. How can you use your DocuCam while you are presenting? Miss Malik, excuse me, did that yesterday. Can you use your DocuCam
Yes.
while you
Yes.
are? Thank you.
Yep, absolutely. Thank you for bringing it up. So the easiest way that I have found, and I'm sure other people have found other routes, the easiest way that I have found, so let me clarify, you're talking about your actual document camera from your classroom, true?
Correct. Like Miss Malik did yesterday, how she showed the squares and what have you. Yes, how you use your DocuCam. Yes, ma'am.
So I'm going to back up a little bit because I've seen this done, but I haven't done it myself, but I'm going to ask somebody on the call to share. How does that work?
So yesterday, oh, go ahead. Is that Sonia?
No, go ahead, Sharon. Go ahead.
So yesterday, Sonia used an iPad. So it wasn't an actual document camera. She used the iPad, had it set up with a holder. And there's a way through, when you share your screen, there's a way to share like an iPad or an iPhone through the Google Share. Now, another way you can do it is just to log on with, into like the Zoom with another device like your cell phone. And you can use your cell phone as a document camera and use the camera from your cell phone, you know, to and face it towards the paper and things like that. And you can use your cell phone as a document camera as well.
Thank you.
You're welcome.
Can I just wanted to share something
Yes,
in
please.
regards to document camera. You can, my computer, I have 2 screens. And so you can use the dual screen option as well. So whatever screen you're showing is good as what's going to be showing up.
Okay.
Does that make sense?
Yeah, well, and every time we hear one of these ideas, it's like the best thing I can tell you as participants to do is to go and try it out.
Yes,
because
for sure.
One really beautiful thing about these days is that it's much more user friendly than when you and I were children and you know everything was in like crazy syntax. So I have found when people give me a little idea like that, I just have to tell myself I'm going to go try it out and see how it works. But we are also going to stay on the call when we finish here, and so if you want a little bit more guidance, we can certainly stay on for a few more minutes. So just another resource for thinking about engaging kids in tasks, but also gathering their reasoning. If you haven't seen Slides Mania, and we will put a link for you. You can create these interactive or digital notebooks. And so there's a lot of things to like here. I like this little GIF. It helps students kind of get a sense of what this problem is talking about. There's also multiple ways in which the mathematics is represented for the students in a graph, in a chart, in the word problem. And then they just have to type into text boxes in order to give their responses. And it's up to you to go ahead and design what those are. But we really liked this one that was really focused on explaining your thinking about these runners, where they're at in the race, and their average speed throughout the race. So you can find those at Slides Mania. Okay, so I've done a lot of talking. Sorry for that. That's not normally my mode, but we felt like we had a fair amount of information to get through. Now I want to give you a chance to share some things. So I have a few questions I'm going to bring up one at a time. And I just want you to go to the chat and respond to these questions. So just one at a time here. This first one is, how can you set norms in a virtual environment to encourage problem solving and collaboration? So let's learn from each other right now. How can you set norms to encourage problem solving and collaboration? Okay, talk about the expectations. Let students know what is expected during that time. Yeah, you could set problems out ahead of time, give them time to think and prepare, but then come together for discussion of their responses. Yeah. Yeah, we know that setting up routines and getting expectations in place means that we have to be consistent over time. Giving them jobs to do. I love this. So in elementary classrooms, elementary teachers are really good at giving kids jobs. You could give them jobs inside the digital space. Do it as you engage in instructional routines. Yeah, build the norms together. And then kids can decide, what does it look like to be productive in this space? How are we going to have to behave? What would we expect of the teacher? What might we have to say to our siblings? All really good responses. So here's another question for you. How can you structure time for students to work together in their problem solving? How can you structure time for students to work together? We know that they learn from each other. They use each other as a resource. Breakout rooms. What other ways? Think about synchronous when we're here in a call together, but also asynchronous. Yeah, so they can respond to each other in the Flipgrid. Collaboration stations, those breakout rooms could have a different name. Work on a slide together. Yeah, so if we have a shared slide deck and 2 or 3 students are going to the same slide, they could work together and then have a breakout room. On a Jamboard together. One student shares their screen or they all just observe from their own computer. Record your response and share with somebody else in a video call. Nice responses. One last question. How can you encourage students to share and respond to each other? So not just that they share their thinking, but that they respond to someone else's thinking. So we saw one teacher do that here with Flipgrid. Are there other ways? And one teacher noticed the sentence stems that were given. Provide sentence stems, yes. Establish norms. It's part of setting up those expectations. If these are the things that we want to emphasize in our classroom, is that if this is the culture that we want to build, then we have to establish those norms early on. Okay, thank you, very good thinking. So we have one more document we want to share with you. If you're familiar with Joe Boller, and I will go out to this document so you can see a little bit here. Joe Boller, along with, we know, many other people, put together resources this spring and summer to help us really think about our instruction in a virtual environment. And so in Joe Boller's, she focuses on 4 things: the use of technology, assessment, curriculum, and pedagogy. But what we really like about it is for each of those things, there's a little bit of background information on what the Math Ed research says about that thing. And then there's some really easy things to follow, like what about facilitating virtual gallery walks? So we tried this out earlier this morning with some participants, just put together a couple Jamboards, one right after the other, and asked students or participants to kind of go through it like a virtual gallery walk. So there's ideas in here for how to support this student-centered instruction in a virtual environment. And so we really recommend that you spend some time looking through there and seeing how it could support your thinking about teaching this fall. I really thought it was quite, I don't know, it was just kind of perfect, but this is a quote that's on, I think, page 9 of the document. By centering instruction around student thinking, each learner is positioned as a contributor to the classroom community, and that supports a sense of belonging and identification with mathematics. That would be so nice to see students identifying themselves as a math learner, as a user and doer of mathematics, and we really want to build that community for them. So I'm going to take a breath. Does anyone have questions at this point? What questions do you have? You can unmute and we'll just talk together.
Notice we
Hi,
are
it's Jessica from Wayne.
I'm sorry, what's that, Jessica?
Sorry. I was just gonna let the group know that I know that there are virtual manipulatives out there as well to engage students on mathematics. So you might want to, search for those. I just want to throw that out there for the group.
So I'm actually gonna put Sonia on the line here, and Sonia has a link to like a Bitmoji classroom where it has clickable virtual manipulatives all set up for an elementary classroom. And I'm wondering, Sonia, if you can share those. Are you still there?
Yes, I'm here. Just give me a second.
Okay. So I think it's a link that she can put in the chat. So thank you for bringing that up, because that's another piece of kids being able to access and think about the mathematics. Any other questions?
Well, I don't have a question. I have a comment.
Okay.
I just actually got off another workshop. It was actually a good workshop of dealing with virtual mathematics and Eureka Math. But while they talked a lot about, how the teacher is to, disseminate the lesson virtually, they touched on, the child's independent part in, learning the process. But I like you guys went into a greater detail as giving the children more of the power in learning the process and facilitating that strong dialogue, even though it is virtually, with everyone will be in the queue. So I really enjoyed that.
Thank you, Jerome. And hopefully the two things together really help you think powerfully about instruction this fall. And you've got me a little bit kind of emotional, because it's when we walk into classrooms and see students in that space where they are being positioned as problem solvers, it's just a really great feeling to see them having that ownership. And we want that for all students and for teachers as well. It's a great thing. All right, so I'm trying to be mindful of the time. Thank you for the comment. We are going to stay on, but for sake of those who need to head out to do something else just now, we invite you to share feedback with us. We're learning this whole virtual thing ourselves. I think all of us feel like we are brand new teachers this year, and there's all kinds of things that we have to figure out. And so we're learning as well as you. So please give us feedback, and it will help us with two things. How did things go today? But also, what other things can we help you with as we go throughout the school year this year? We'll give you a moment to use your camera to get that feedback form. We're also going to put our contact information back up. There's actually 5 consultants at Wayne Risa. There are 3 of us on the call today, and Sonia sat in. Thank you, Sonia, for sharing your virtual manipulatives. The feedback form, and you want, you need to go and take care of other things today. We thank you for joining us. And if you want to stay and ask questions, the math consultant team is going to stay on and respond to anyone who has specific questions or more wonderings about this fall and working virtually.
We just want to say how much we appreciate you just engaging with us in this day. We had a great time with you. You were great participants and shared lots of your ideas and thoughts, and we appreciate it. It sure does make our presenting much easier when we have a great group like all of you. So thank you.